we will learn about residual for line of best fit. And what residual does is it determines if our model our model line, our model equation is a good fit for our data set. So in this example, if you haven't yet plotted those points on your graph, what you'll want to do is pause the video, plot the points using the scale that we have here I've made, and then we're plotting this equation, y equals negative 2x plus 20. So you're going to want to put that in your graph also. Residual is the distance away from our data points away from our model equation. So here's our model equation. And if we have some points above or this point below, and then sometimes we have some points on the line. And what the residual is that distance away from the line. And it's the y value distance. So it's this distance right here. So that's our residual, and it's and they're positive because this one is above the line, so it's a positive residual. This one down here that's below is a negative residual. Okay, so that's that difference. This one is on the line, so there's a 0 residual for that one. So what we're going to do is determine that if it is. So what we have to do is take and create a table, and it does a really nice job of organizing that in. So we have our x and y. This is a horizontal one, so we'll change it to a vertical one. 1, 2, 3, 4, 5, 6, 7, and 8. Just so it'll be easier to organize like the calculation piece of it. So 19, 15. All right, so we've got our data sets and these are the data from the actual data. So now in our next column, what we're going to do is we're going to calculate the y values for our model. And that's for our equation, y value for our equation model. So when we have those, what we'll do is we'll substitute 1 in for x. So negative 2 times 1 is negative 2 plus 20 is 18. We'll do that for 2, which is calculates out to 16, 14, and then we use our slope, 10, 9, no, 10, 8, 6, and 4. Now, how to find the residual is what we do is we take and subtract the y value models away from our data set. So it's using your data, the actual data we're given, and then subtracting the model away from it. So we will calculate each of these out to find that residual. Okay, so that's going to be our last column over here. So our residual for the first one is 19 minus 18 is 1. Then 15 minus 16 is a negative 1. Negative 1, negative 1, 0, 0, positive 1, and positive 1. So what we're looking for is an even distribution. So a good model is an even distribution of the residual. And what that means is that there's some on the top and some on the bottom. And so what we can do is we can plot those points on a kind of a number line. Now, a lot of times we'll plot it right here on our x-axis because that's what this is. This is our x-axis. and our y-axis here. So I'm going to go ahead and number them. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then when I plot my residual here, we're going to plot them so 1 is 1, 2 is -1, 3 is -1. Oh, there's 3 in a row all the way to 4. Then 5 and 6 are zeros, so we'll put them on the x-axis. And then 7 and 8 are +1. So if you notice, there's 3 positive ones on top, 3 negative ones on the bottom, and that is why this is a good model. Wait, this is a good model. So our y equals -2x plus 20 is a good model for that data. And so that even distribution is a key piece of that residual. Now, there might be a different pattern that happens where it's not. So if there's all on the negative side, that would be not a good model because they're not evenly dispersed.